In this video, we're going to be going over how to add and subtract rationals. The key thing to remember here is that in order to add or subtract them, you have to have a common denominator. This is the same rule that applied when we were first working with fractions. So if we take a look at our first problem here where we have a 1/4 plus 2/4, when we were learning how to work with fractions, we first made sure that the denominator was the same. In this instance it is, so we went ahead and you would keep the denominator and you would add your numerators. So I would take my 1, let's get a different color here, and then I would add it to my second numerator. And we would arrive at our answer of 3/4. This was the easy case when your denominators were already the same. If we look at this other problem, we notice we have a 1/4 plus a 2/3. Well, how did we add those fractions? When we first looked at it, my denominator was not the same, so we had to think, what can we turn both a 4 and a 3 into? And in that instance, we could turn them both into a 12. So we would want to have our denominators being a 12. I would get that in the first one by multiplying the first fraction, top and bottom, by 3. So I would get a 3, which was from the 3 times 1, over 12, which came from the 3 times 4. And the second fraction, I would multiply top and bottom by 4. So I'd end up with an 8 over 12. Now we have, change color here, the same denominator. So we would keep it and we would add my numerators. So I'd have a 3 plus an 8, which we would then arrive at our final answer of an 11/12. So hopefully you remember doing that type of work with your regular numerical fractions. What we are going to be doing now is making it a little bit more complicated, because we are going to start dealing with variables and having expressions in either numerator or denominator, or sometimes both, and we're still going to be asked to add or subtract these fractions together. So let's take a look at our first example that has variables in it. If we look at this one, looks complicated because we have those trinomials there at the bottom. We have a 4 over a 5x squared minus 22x plus 8, and then subtracting a 5 over 5x squared minus 22x plus 8. So we first want to check to see, in order to add or subtract fractions together, you have to have a common denominator. Well, in this first one, my denominator is a 5x squared minus 22x plus 8. In my second fraction, my denominator is also a 5x squared minus 22x plus 8. So that is going to stay, and that's going to be the denominator. A 5x squared minus a 22x plus an 8. And we're going to take our numerators and we're going to subtract them. So I'm going to have a 4 minus 5. Now I can go ahead and simplify. In the numerator, 4 minus 5, that gives me a -1, and I don't have to do anything but copy down my denominator. So I've arrived at my final answer right here. Let's look at another example. So here we have a p minus 4 over a 6p plus 24 being added to a p plus 4 over 6p plus 24. Again, our first step is, when we're trying to add or subtract fractions, is to make sure we have a common denominator. The denominator of my first one is a 6p plus 24, and the denominator of my second one also is a 6p plus 24. So we have a common denominator. We're going to go ahead and keep that. That's going to stay as our denominator. And then we can go ahead and add our numerators. So I have that p minus 4, and I'm going to add my other numerator, that whole thing, a p plus 4. Now, in the other steps, we've essentially been able to just add and be done. Now we have to look to make some simplifications. So here, in the numerator, what I'm looking at, I have the parentheses, but all of my operations are either addition or subtraction. So I don't really need those parentheses in this case, so I can just go ahead and combine like terms. So if we look at this, I have a 1p here and another positive p here. So that's going to give me 2 p's. And then I'm going to try to find another color here. Look, we have a -4 and a +4, which is going to combine to give us a 0, so I don't have to write that down in my numerator. Now all I have to do is copy down my denominator, so 6p plus 24, and I have what would appear to be a final answer. But in this particular instance, it's not going to be our final answer because there's some factoring we can do to simplify this. If we look at our denominator, we notice that we can factor out a 6. So in my denominator, I can factor out a 6, which would leave me with a p plus 4. My numerator, I still had that 2p. Now that we do that, we can take a look at this fraction right here. We have a 2/6. Well, if we were looking at that fraction, we could go ahead and simplify that fraction by dividing top and bottom by 2, which would give me a 1/3. That was just our basic rules of simplifying fractions. So we can essentially kill this guy, he gets replaced with a 1. Kill that guy, he's going to get replaced with a 3. So now all we have to do is put together our final answer. We have a p in the numerator, and now we have a 3 and a p plus 4. You can leave it like this, or another acceptable way to write that answer would have been to go ahead and distribute that 3 again and end up with a 3p plus 12. Either one of these I would accept as a final answer. So far, both of these examples have dealt with the cases where our denominators were already given to us as the same. That's not always going to be the case. So let's look at an example where right off the bat we don't have a common denominator. So if we look at this, right here my denominator is a 2x, and over here on the other side I have a 2x squared plus a 4x. Well, that is obviously not the exact same thing as a 2x. So what I'm going to do is I'm going to look to factor. So I'm going to look at this denominator right here and see what I can factor. See if I can factor it out. So I'm going to come off to the side here and write a 2x squared plus a 4x so you can see a little bit better what we're doing. When we were factoring this, we want to look for a common factor. So what is a common factor that I can pull out of both? In this instance, I can factor out a 2 and I can factor out an x. And if I do that, that's going to leave me with an x and a positive 2. So our denominator that I've circled there in green factors down to a 2x times, in parentheses, an x plus 2. So I'm going to go ahead and replace that. So first I need to go ahead and copy down that first fraction because I haven't touched it yet. So we had a 4x over a 2x minus, I didn't mess with the numerator, I changed the denominator. So I'm going to replace that circled part with what we found over here to be the factored form of it. So now I have a 2x and an x plus 2. Now we want to again see if we have a common factor. If we look for our common factors, or common denominator, we have a 2x here. We also have a 2x there, but I'm missing a little piece. In one fraction, I have that x plus 2, but I don't have it in the other guy. So my common denominator is going to end up being this guy right here. That would be my common denominator. So what am I going to do to the first fraction to get that as a common denominator? I'm going to have to multiply it top and bottom by that x plus 2. So when I do that, I'm going to go ahead and switch the order so that it looks like what we're used to looking at. We have a 4x, and then it's going to be times that x plus 2. And all of that is now over my 2x and what we just multiplied by, our x plus 2. Then we had our minus, copy down our fraction. We have a 5 over a 2x, x plus 2. Now if we look at this, we now have a common denominator. So from here, that denominator is going to stay. We're going to use that as our denominator. We have a 2x and an x plus 2. And now we're going to go ahead and subtract our numerators. So I'm going to take all of this guy and write him down. So a 4x times an x plus 2. And I'm going to subtract this 5. Now from here, I need to go ahead and get rid of these parentheses. So I'm going to go ahead and distribute. So I'm going to take that 4x times the x. That's going to give me a 4x squared. I'm going to take that 4x times that 2. That's going to give me a positive 8x. And then I'm going to subtract the 5. So I have all of that over my 2x, x plus 2. And we've arrived at our final answer. Let's look at another example like that. So here if we look at this one, we have a 6 over a minus 1 minus a 6 over 5a plus 4. If we look for a common denominator, in the first guy I have an a minus 1. In the second guy I don't have an a minus 1. I have a 5a plus 4. Can I factor a 5a plus 4? No, that's not good. I can't factor that out. So I'm going to use both of these denominators as my common denominator. So the first guy is missing the 5a plus 4. So I'm going to have to multiply him by 5a plus 4, top and bottom. The second guy is missing the a minus 1. So top and bottom, I'm going to multiply by a minus 1. So the first guy, I have my 6 times a 5a plus 4 all over an a minus 1 times a 5a plus 4. Then I have minus a 6 times an a minus 1 over, I'm going to rewrite these. The order that we multiplied doesn't matter, so I'm going to keep it in the same order and write that a minus 1 first and the 5a plus 4 second. Now it's easy to tell that our denominators are now the same. We have an a minus 1 times a 5a plus 4 over here, and also over here an a minus 1 times a 5a plus 4. So that is going to be my common denominator. So I'm going to go ahead and write that down. I have an a minus 1, and I have a 5a plus 4. Now I'm going to take my numerators. I'm going to take all of this guy. So I'm taking that 6 times the 5a plus 4. And I'm going to subtract this guy. A 6 a minus 1 So now I'm going to go ahead and distribute that 6 times the 5a and then the 6 times that 4. So I have a 30a plus a 24, and over here I'm going to distribute that 6 to the a and the minus 1. minus everything I get here, a 6a minus 6. That is in my numerator. My denominator stays the same, an a minus 1, and a 5a plus 4. Now I still have a negative in parentheses, so I can go ahead and distribute that negative like it was a negative 1. So that's going to change a sign here. So I'm going to have to go to another page here. So hopefully we don't get confused here. We have a 30a plus 24. And then we had the minus that was being distributed to that 6a. So that gives us a minus 6a. And the minus a negative. So the minus and a negative becomes a plus 6. All of this was over an a minus 1 times a 5a plus 4. Now I can combine like terms in the numerator. I have 30a minus 6a. That's going to give me 24a. I have a 24 plus 6. That's going to give me a positive 30. And all of this is over my denominator of an a minus 1, 5a plus 4. And here is our final answer. Let's look at another example. So in this example, we have a 3 over a 6k minus 3 minus a 6k over 5. Again, we still do not have a common denominator in this example. But what I do notice is in the denominator of the first one, I can go ahead and factor that. Most of the time, factoring things early on makes the problem a little bit easier to work with. I do have the option to just use a 6k minus 3 and a 5 as my common denominator, but then in the end, I'm going to have to factor that down. So I'm going to go ahead and factor first and see that in that denominator I can go ahead and factor out a 3, and that would leave me with a 2k minus 1. Let me change color here. So I factor out the 3, and that would leave me with a 2k minus 1. And in the top I still had the 3 that I had not touched. And I still have my second fraction that I haven't worked with yet. So now when I look for a common denominator, this guy has a 3, and it has a 2k minus 1. And then the other part, the other fraction, I have a 5. So my common denominator is going to include all three of those colors, the blue, the orange, and the purple. So I'm going to get that by, in this first fraction, I am missing the 5. So I'm going to go ahead and multiply top and bottom by 5. That would give me all three colors. On that second fraction, I'm going to need to multiply by the 3, top and bottom. Now I have the blue and the purple, and I'm still going to need to multiply by that orange because I'm going to need all three colors. So I had the 2k minus 1, top and bottom. So now I'm going to have a common denominator of that 3 times the 2k minus 1 times the 5. I can take the 3 and the 5 and go ahead and multiply that. So that gives me a 15 2k minus 1 all over my 3 times the 5, which is a 15. And the second guy, I still have the same denominator. The 5 times the 3 was the 15, and the 2k minus 1. And in the numerator, I have a 6k times a 3, which is going to give me an 18k, and times that 2k minus 1. So I can go ahead and distribute now, or I can add fractions together. This one I'm going to go ahead and distribute that 18k first. So before I distribute and write it down, let's copy down this first guy, 15 over a 15 2k minus 1, minus, now when I distribute what I circled there in the blue, that 18k times that 2k, 18 times 2 is 36, so I've got a 36, k times k is k squared. Then I'm going to take that 18k times that negative 1, which gives us 8 minus 18k. All of that was over our denominator of a 15 2k minus 1. Now we have the common denominator. So I'm going to come over here. I got enough room here at the side of the board to keep my denominator, that 15 2k minus 1. Now I'm going to take my numerator, all of this guy, which is just 15, minus all of this guy. So I need to use parentheses. There's more than one term there. So minus the 36k squared minus the 18k. Now I need to distribute. I still have that parenthesis to deal with, so I can go ahead and distribute that negative to both of these, leaving me with a 15 minus 36k squared and a plus 18k all over a 15 2k minus 1. Now if we look at that numerator, it's not in standard form, so I'm going to go ahead and rewrite that and put it in standard form. Standard form is in decreasing order of your exponents. So when I do that, my numerator is a, change color here, negative 36k squared plus an 18k and plus a 15. All of that was over our denominator of a 15 2k minus 1. Now we want to look to see if we can factor. If we notice in that first one, there's a common factor, a number that we can factor out of all of them, and that would be a 3. So if I factor out a 3, that's going to leave me with a negative 12k squared plus a 6k plus a 5 all over a 15 times a 2k minus 1. Now we can look at our numerical fraction here of a 3 over 15. If we think back to simplifying fractions, I can divide top and bottom by 3, and that's going to simplify to a 1/5. So this essentially kills each other out, becomes a 1. This guy dies and becomes a 5. So 1 times anything is still whatever you multiplied it by. So I'm copying down that negative 12k squared plus 6k plus 5. And now in the denominator I have a 5 times the 2k minus 1. And this would be an acceptable final answer. You could also go ahead and distribute that 5 and end up at a negative 12k squared plus 6k plus 5 over a 10k minus 5. Either of those would be an acceptable answer. Let's look at one more example that gets even a little bit more complicated. Here we have an x minus 2 over a 3x squared minus 7x plus 4 minus a 3x over 5. Concept is still the same. The only thing that makes this slightly more challenging is that you have this trinomial that you need to factor. So this goes back to your A times C method that we reviewed in previous videos. We're going to take the 3 times the 4. That's going to give us a 12. We want the factors of a positive 12 that are going to add together to give us a negative 7. Well, in order for two things to multiply together to give us a positive number, they're either both going to be positive or they're both going to be negative. Since we want it to add together to give us a negative 7, our factors are going to be a negative 4 and a negative 3 because that's going to add to give us the 7. So we would rewrite and factor from here using those factors. We have a 3x squared minus a 3x and a minus 4x and a plus 4. I just rewrote that middle term. Now I can factor by grouping. So here I can factor out a 3x out of both of those terms. That's going to leave me with an x and a minus 1. Then I'm going to look and factor out the next ones. So here I can factor out a negative 4. And that is going to leave me with an x minus 1. And here's where we're looking. These should be the same if we factored correctly. They are. So that's going to be one of them. And then what's my next one? It's those there in orange. What was left? A 3x minus 4. So my factored form of that denominator we circled up there in blue is this guy. So we're going to go ahead and replace it. So we have an x minus 2 all over my new denominator, an x minus 1, and a 3x minus 4. Then we still had that second fraction we haven't touched, the minus 3x over 5. So now we can look for our common denominator. Well, we know we have an x minus 1. We don't have it on the second side. We also have our orange right here. And let's pick a new color. And we have this. So our common denominator is going to require all three of those colors. So on the first guy, I'm missing the 5. So I'm going to multiply top and bottom times 5. And on the second guy, let me make some room, erase this stuff over here. I'm going to need to multiply by the blue, which is the x minus 1, top and bottom. And I'm going to have to multiply by the orange, 3x minus 4, 3x minus 4. So now I can go ahead and make our distribution in the numerator. I have a 5 times an x minus 2. So I'm going to go ahead and distribute that to both pieces. That's going to give me a 5x minus 10. And that is all over our denominator of a 5, an x minus 1, and a 3x minus 4. And then over here, I'm going to have all of this guy. I'm going to have a 3x. Then I'm going to go ahead and multiply those, the blue and the orange. So let's go off to the side here so you can see what's going on. We are going to take that x minus 1 times the 3x minus 4. This is FOIL, double distribution, whatever you want to call it. And x times a 3x gives us a 3x squared. And x times a negative 4 gives us a negative 4x. A negative 1 times the 3x is a negative 3x. Negative 1 times negative 4 is a positive 4, leaving us with a 3x squared minus 7x plus 4. So we have our 3x squared minus 7x plus 4, all over our common denominator, 5 times x minus 1 times a 3x minus 4. I still have a distribution to make. I still have that guy that needs to go to all three places. So here I still had my 5x minus 10 over a 5x minus 1, 3x minus 4, minus, now I can go ahead and make that distribution there. I have a 9x cubed minus a 21x squared and a plus 12x all over our denominator of 5x minus 1, 3x minus 4. So now I have common denominator. I can go ahead and subtract my numerators. So obviously I'm out of space. We're going to have to move on to another screen. So I'm going to take all of this guy. So let's go write him down. A 5x minus 10, and I'm going to subtract all of this guy. So I'm going to put him in parentheses. I'm going to subtract a 9x cubed minus a 21x squared plus a 12x. And all of that was over our denominator of a 5, an x minus 1, and a 3x minus 4. Minus 4. So now from here, we're going to distribute that negative into all of those places. So I have a 5x minus a 10 minus a 9x cubed plus a 21x squared and minus a 12x. All of that over a 5x minus 1, 3x minus 4. Now I can look to combine like terms and put in standard form at the same time. So my highest exponent is that x cubed there. So I'm going to write him down first. There's no other x cubes on there. So I have a negative 9x cubed. The next highest exponent would be a squared. Well, I have a plus 21x squared right here. So I've taken care of him, I've taken care of him. Now the next one is going to be the exponent of 1, or just those x's. So I have a 5x minus a 12x. That is going to give me a negative 7x. And then I still have that minus 10 that needs to be accounted for. So minus 10. All of that is over our common denominator, the 5x minus 1, 3x minus 4. And we've arrived at our final answer.